So in this video, we're going to talk about the key features from this rational function graph. So it's the graph of 1 over x. So the first key feature I want to look for is the x-intercept. And so if I look at the graph, I want to look to see where do I cross the x-axis. And you don't cross the x-axis. So for this graph, the x-intercept, there's none. All right, you don't cross the x-axis. If we were to look at this, to find the x-intercept, you want to make y equal to 0. Well, g of x, remember, is the replacement for y. So if we wrote y is equal to 1 over x, well, we would get 0 equals 1 over x. Okay, easy enough. Now let's say we want to solve for x. Well, we could put this over 1 and cross multiply. So 0 times x is equal to 1, which means 0 is equal, we have a small problem here. 0 does not equal 1. 0 will never equal 1. So there's no way to make an x-intercept for this problem. Now, obviously, we found that visually first, but that's what we're looking for here. Second thing I want to look for are my y-intercepts. So let me slide it up to my graph. And I want to look to see where I cross the y-axis. And yeah, I don't cross the y-axis. Okay, so y-intercepts, none. All right. Now, remember, to find the y-intercept, you would make x equal to 0. So if we start with y is equal to 1 over x, well, I'm going to replace x with 0. So 1 over 0, the y-intercept, if you were to write anything, would be y is equal to undefined. Except apparently I can't spell undefined. Undefined. There we go. Which doesn't make any sense. All right. Undefined literally means undefined. There is no numeric value there that makes any sense for this. So we say that there is no y-intercept. Again, visually, if you can find it, awesome. Okay. Domain, remember, are your possible x values. So I'm going to put that here. So possible x values. All right. So if we look at our graph, and I look across the x-axis here. So on the negative x, yep, we have a curve. We have this, not so great curve because, well, I can't draw that well, but we've got this curve. It goes all the way up to, but we can't include 0. All right, so no 0 here. And then right on the other side, we can get right up to 0, but can't include it. And then we have all these positive values. So the domain is everything except 0. So negative infinity all the way up to 0, but don't include it. That's why we use the parentheses. Joined with 0 to positive infinity. Okay, so this is your, the way you write your domain. Range are your possible y values. There we go. So if I will look at my y-axis, right down here, we have the curve. We can see it going up, 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 up. It shoots off to the left, but those are still y values there, okay? But we can't have a y value of 0, or else we would have had an x-intercept, so there's no y value of 0. But if we get right above 0, yeah, curve shoots off to the right here, but it comes all the way back over and up. Yeah, we're good. Everything except for 0 works. So negative infinity to 0 joined with 0 to let's try an actual infinity. There we go. Now remember, with the interval notation, the brackets mean you don't actually, the parentheses means you don't actually include the value of 0 in your answer. So you can get right up to 0, but not actually include it. So those are your domain and ranges. Now for something a little bit new. We have something called a vertical asymptote and a horizontal asymptote. The vertical asymptote is going to be any x value that was thrown out of the domain. So if we look at our graph, right, and the vertical asymptote here, let's see how well I can draw this line. And I want to make it a little bit thinner, though, because it's really large right now. So if I were to look at the y-axis here, okay, and I'm just highlighting it kind of in this red color, our graph approaches the y-axis either from the left or from the right, but it never actually touches the y-axis. In this case, that's going to be our vertical asymptote. And there is a horizontal asymptote. I'm going to go ahead and color that one in as well. In this case, it is the x-axis. Again, you can approach the x-axis, right? Our graph is getting thinner, or not thinner, but closer and closer and closer to the x-axis, but it won't actually ever cross or touch it. Same thing over here. We're getting closer and closer and closer on the negatives, but you're never going to actually touch it. So the vertical asymptote is this vertical line right here, where x is equal to 0. So vertical asymptote is x is equal to 0. And the horizontal asymptote, let's go ahead and go back here, is this horizontal line right here where y is equal to 0. Okay? So that is our, let me do a little boxing up here of final answers so you guys know that those are good. Vertical asymptote is x is equal to 0. Horizontal asymptote, y is equal to 0. Let's catch my range here. There we go. And let's see, no x-intercepts and no y-intercepts. All right, so that's the original 1 over x function. Now, not all rational functions have those exact same answers. So we have an example here that is a transformed graph. Now, I'm going to do a quick reminder about transformation. We're going to do a lot more with transformations in lesson 2, but just as a quick reminder, okay, we have a transformation right here that's attached to x, and we have a transformation right here, right, that is attached to the function. So x minus 2, this minus 2 is a horizontal shift. And this is the goofy one. It's going to shift to the right 2 spaces. And then we have this where we added 1 to the entire function. This is a vertical shift. Whoops, there we go. Shift up 1. Okay. Now, one of the first things that I might recommend that you do is that you take a moment and you actually find your vertical and horizontal asymptotes. I know those are some of the last things, well, they're kind of in the middle here, but I would absolutely mark those first. So we've got a vertical asymptote right here, right? If we draw that vertical line, and I know because of the thickness of the highlighter, it's kind of hard, but this curve is going to approach it. This curve is going to approach it, but never actually touch it. So that's the horizontal one. And then I can do the same thing for the, no, that was the vertical one. This is the horizontal one. Right here. Again, curve approaches it and curve approaches it, but doesn't actually cross or touch it. All right, so if we start at the top, X-intercept. So where do I cross the x-axis? Ooh, right here is where I cross the x-axis. So that's going to be the point 1, 0. So that's this point here in pink. Okay. Y-intercept. Where do I cross the y? Well, I do cross the y-axis. I'm going to put a little purple point there, but I can't exactly tell what it is. So off to the side here, for my y-intercept, remember you make x equal to 0. So y is equal to, and I'm going to use the rest of this function here. So 1 over x minus 2 plus 1. Replace x with 0. And so I'm going to get, and by the way, this whole thing can go in a calculator at once. So let me pop up and see if I can find Desmos. I can. I will make Desmos do my work. It's kind of nice. Apparently needs to make Desmos turn on. All right, so I'm going to make this fraction here. So numerator is 1, denominator is 0 minus 2. And I'm actually going to show you one other quick thing. So plus 1. So that's 0.5. Let me see. Can I make that into a fraction? Oh, I can. So that's going to be positive 1/2 or positive 0.5. So my y-intercept is going to be 0 and then 1/2. Now, one quick thing that I want to show you with Desmos, if I try and take 0 divided by 1, Desmos is nice and actually tells you it's undefined. If you're using Calculate 84, you might just get an error message. And that's okay too. All right, vertical asymptote. Let's see what we've got here. The vertical asymptote was this vertical line. Vertical lines are always x equals, and it's x equals wherever you cross through the x-axis. So vertical asymptote at x is equal to 2. Horizontal asymptote, well, we shifted up 1 unit, so we're going to say that that's going to be y is equal to 1. Now, your domain is going to be every value except for your horizontal asymptote. So it's going to be negative infinity to, positive 2, and then 2 to infinity. And your range is every value except for the horizontal asymptote. So negative infinity to 1 joined with 1 to infinity. All right, let me go ahead and get rid of Desmos there and make sure I've answered all the questions on this page. All right, so a little bit of a review about transformations, but the important part is being able to find all the key features from the graph. I'm going to go ahead and close this video out. There is another part to this page that I'll pop up with the key, but I'm not going to make a video unless somebody asks for it. So if you do have any questions or concerns about the review,